Okay, let's start. Good afternoon, good morning, everyone. I'm Stefan Sanker from Methodin. I'm a research and consulting services manager, and I'm pleased to give this talk now. Thanks you to attend the web conference today. This is an English session. We are almost now exactly 41 connected for this session. The session concerns the assessment of pedestrian wind comfort in urban area with numerical tools. So, the contents of this conference are the following. So, firstly, I would like to explain how to assess the pedestrian wind comfort by introducing pedestrian wind comfort criteria. The pedestrian comfort depends on each country regulation according to various guidelines. The pedestrian wind comfort is space dependent in urban area, so master plan designer should have some knowledge about the influence of master plan on comfort mappings. And at the end, I would like to introduce UrbaWind, a CFD tool dedicated to assessing the pedestrian wind comfort. And at the end, if we have enough time, I can answer to your questions. So use the chat panel with GoToMeeting, you can do it. And I hope we have time to answer. If not, we can answer with the document we will send later with all the answers. So, about the pedestrian wind comfort. So, the wind is a air motion. This air motion inducing forces on bodies. So this includes change of the feeling and can reduce the safety of pedestrian. The boundary layer above the ground depend on the land cover, depend also on the topography, and depend on the aerodynamic interactions between winds and buildings. So the winds in urban area are strongly different from those nearby meteorological stations. So the question for designer is how to design the master plan. So it's very, very complex. The wind chill. Here we deal only with the mechanical aspect of the wind. So the wind chill, the humidity, the solar radiation, and the clothing are not considered in the wind comfort criteria. Nowadays, wind comfort assessment of new urban project is common practice in most wind engineering team. So that means it's very in lots of projects now it's urban planner need to know what's happened close to building in order to improve the comfort. So the assessment methodology is based today on wind speed threshold and on frequency of accidents of these threshold. So, but the comfort depends also on the pedestrian activity. Nowadays, there is lots of rules in the world, so different assessment methodology are given in each countries. So now we can speak about aerodynamics. So a few words about the wind description. The turbulence, it's a three-dimensional random process. So you can see on the picture a signal of a wind. It's very, very fluctuating, and this is three-dimensional. So you can have some information to describe the wind. So there is the main component. This is the wind speed U, and there is two other orthogonal components because this is three-dimensional signal. So V and W. But to describe the wind, it's easy to keep only two components, two quantities. So this is U for the mean wind direction, and the turbulent intensity. This is EE at the end of this slide. This is the ratio between root mean square. This is the standard deviation divided by the velocity. So to describe the wind, we reduce the number of variables in order to describe. So now, if you want to speak about comfort, we need to know which wind we use. So, a quantity is very important is to define the gust speed definition. The gust speed is it's the value of the velocity of the wind can be arrived in the area like this. This is there are two variables. This is the mean or the gust. So the velocity that of the wind used to assess the comfort is different. It depends of the country. Here there is, for example, three value. So 4 value for comfort and 1 value for safety, and it is not the same approach. If you use the gust speed for safety, you use a definition like this. The mean speed is defined on the average sapling duration t, about 10 minutes, and the coefficient alpha is roughly 3. But if you use a comfort criteria as in UK for Lawson criteria, the criteria is defined by only the mean value. There is not a gust speed, but the t equal 10 minutes. In France, it's different. We use a criteria with a mean value plus a standard deviation. In Netherlands, it's different because we use a velocity wind speed with the average value on 1 hour average value with alpha equals 0. There is no fluctuation. So here you can see lots of criteria. So the gust speed is different. So here this is the wind comfort categories. Wind comfort criteria are based on the frequency of wind speed, threshold, exceedance, and on the pedestrian activities. On the right side of the slide, you can see the Lawson comfort criteria. So this comfort is very useful because we can understand what's happened in the for comfort. The comfort depends on the wind speed. Here, this is the scale is the Beaufort force, and here this is the percentage of time exceeded. So you can see here it's comfortable if the mean speed, if the percentage is between 0 to 1%, for the wind speed between 0 to 3 on the Beaufort scale. It's different if you have a walking or a running here, for example. It remains comfortable if the percentage is between 2 and 6 for wind speed between 3 to 5 Beaufort scale. So you can see on this picture is very if you want to assess the comfort, you need to know the wind speed, you need to know the time of exceeding this wind speed, and you have to know the activity of the pedestrian. Other point in this can be summarized in for guidelines in the world. So in this chart we collect all the information for lots of countries, but there is other one if you go in the literature. Wind comfort is there is 4 categories in this chart. It's for long stationary, it's sitting, for example. Short stationary, it's if you are standing. Recreational motion, if you move slowly, and transitory motion if you run or with a quick walk. And you can see the comfort is achieved if you respect this criteria, and the criteria is different. This is the frequency of exceedance. The velocity is different. So, and the activity are here. So, if you want to assess the comfort, you need to know which wind velocity definition you use. You have to know which activities, and we have to know which country. So now we know the guidelines in the world, so how can we assess the wind comfort? It's very, very difficult to use the meteorological station to assess the comfort, because the wind in the meteorological station is very different from your project. Usually the meteorological station is close to airport, so it's a very high wind, I know, with low turbulence. But your project usually your project is close to downtown or in suburbs, so we have less mean velocity but high turbulence. So it's very difficult to use directly the meteorological station data. So in our approach, we want to show you the importance to assess the wind in the urban area. In this picture, we have compared the meteorological station data. It is a distribution of wind here on rows here, and you can see from a lot of points we extract the rows, and you can see it depends on the position of the point. Here this is the east wind, like close to the station, but in this point the wind comes from south. Here too from south, so it's very, very spacing dependent. In urban area, there is lots of aerodynamic effect due to the position, due to the aerodynamic interaction between wind and buildings. The main effect is named Venturi effect. It's due to speed up between two buildings or rows of buildings. So the discomfort in this situation is mainly due to high winds. There is some speed up, as you can see here in this picture computed by UrbaWind. So the question is to know for which direction you have a speed up on the level of the speed up. Other effect, well-known effect, is corner effect. It's due to flow separation close to a corner. Here, a corner of a building, you have the same EC here. So you can see on this picture there is a speed up area, and the question is not only the speed up, it's also discomfort is mainly due to transition or on turbulence. What is transition? This is a motion of the pedestrian. It comes from low wind area to high wind area. This is a problem of discomfort due to the motion of the pedestrian. And another effect, well-known effect, this is the Wise effect. It's the name to describe a three-dimensional vortices between two buildings, like this. There is a vortex, plus vortices upwind any building. There is another vortex here. And discomfort is mainly due to high turbulent down-flowing winds, and it's very difficult to treat this discomfort area because the wind comes from the upper part of the building, of the facade. So it's a problem to assess the comfort and to improve the comfort. But the reality is very different than theory, because all these effects can be there is a mixture of all these effects. So there is corner or vortices and Venturi effect. All is mixed. It's difficult to separate each effect. So as you can see in this picture, there is a lot of the master plan is very dense. So if we want to highlight the comfort area, you have to use all the synoptic wind direction, because you can have a corner effect for one wind direction, and after you can have a Wise effect for another wind direction. So the discomfort is based on the frequency of wind speed threshold exceedance. It's not based on only one wind direction. So in order to assess the wind, you architect or urban planner needs comfort assessment studies. These studies can be carried out with full-scale experiments, so it's very expensive. They can use a scaled-down model experiment in wind tunnel, and they can use numerical approaches as CFD. So the methodology to assess the comfort, this is the same for all the three approaches. First, you use climatological data from the met station. So climatological data can be given with frequency table like this distribution plus rows, and it can be given by wind time series with the wind and the wind direction. So all the data are input for the urban wind simulation. So for some wind direction, there is a computation. This is an intermediate computation, and at the end, all this data, wind series or wind climatological data plus urban wind direction are merged in order to give climatological synthesis. As you can see on this picture, in order to give some frequency of wind speed threshold exceedance. So now I would like to introduce the methodology used by with UrbaWind to assess the wind comfort. This is our methodology. So there is 3 steps. The first step is to define the project. So it's a site setup. In UrbaWind, you can include topography, buildings, and porous volumes. Porous volumes are trees or edges like this. And all these data are introduced in the project in the step 1. So after we use directional computation, so not all the wind direction are computed. We compute only, I think, 12 or 18 directional computation in order to use this information at the end to assess the comfort. So the step 2 is divided with 3 steps, sub-steps. This met generation, boundary condition, and CFD computations. And directional results are gust and mean speed. So we use this data, gust and mean speed, in order to throw meteorological data to extract comfort mappings. Meteorological data are like this. It's the same I given previously. It's roses or time series. So this is the methodology used in UrbaWind. The master plan information, that means building and vegetation geometries, are given by other software as Google SketchUp or AutoCAD or Rhinoceros and so on. And the format is STL. It's a common format to define data, geometric data. The meteorological data are given by frequency tables or time series, as told before. That means wind speed, direction, and standard deviations. And terrain modeling the same. It's a STL format given by Google SketchUp, AutoCAD, or Rhinoceros. So all these data are collected in UrbaWind, and in order to assess the wind in any complex urban areas. And after you can extract mappings of comfort directly. So it's an important question. I expect for you. Where may you collect climatological data? So this is some example of providers, not only this one, but we use commonly this one. So in France, it's Météo France. So there is some national weather data providers. Usually this is sales service. You can ask for everywhere a point of data from the database of these providers, but it exists in the world of free weather data providers from America. It's an NOAA. with the National Climatological Data Center. And we can use also the databases of the US Department of Energy. So you can find also software, but it's a weather data tool. It's Meteonorm, not free, but not very expensive. And it's at the end, this is new self-service. This is from mesoscale numerical simulation as 3-tier or meteor group or and so on. But this is reanalyzes weather data, and you can ask a point everywhere in the world. But this data can be used in UrbaWind. Yes, you can use it, but for some of them you need conversion, but not very quick, not very difficult, because you use Excel and it's okay. But directly you can use UPW format from Meteonorm or US Department of Energy. And for the other, you need just conversion of time series or Excel, with Excel, for example. For the frequency table, you can ask to national providers. Usually, you need to a conversion of data with a chart. So now I would like to introduce some example. Here, this is a project in Paris, France. For the this is an island. The name is Ile-Seguin. It's on the Seine River. The urban planner would like to assess the comfort and to improve the comfort, because it's very it's a high wind exposed area, because it's on the river. There is no obstacle neighbor. So they would like to reduce, for example, in this picture, the corner effect. So there is some improvement of comfort by positioning some trees or to edges. This is a project in Paris. Another in Paris, it's also for Atelier Jean Nouvel, the architect. It's different because this architect would like to use the terrace for pedestrian. So, but the terrace are not on the ground; they are on 10 meters or more above the ground, in the top of the tower. So there is a lot of high wind in this area. So there is an assessment for that, because they would like to use the terrace for pedestrian. Other example is not in France. It's close to to Luxembourg. At Luxembourg, the project is named Porte de l'Europe, and it's very dense area. So we use UrbaWind to assess the comfort. Here there is a combined effect of Venturi effect, three-dimensional effect, and corner effect, as you can see here. So there is some all this area is okay for the comfort for all the activities, but close to the corner, it's there is some high wind area, and it's uncomfortable. So there is some local treatment here with vegetation in order to improve the comfort. So about the performance of UrbaWind, yes, it's very important to know some performance, because a disadvantage of a numerical approach are time of computation. In order to manage with it, UrbaWind was developed in order to reduce this time. Here, after some example of time of computation for project, and the data given for this computer configuration. It's Intel Xeon 2.4 GHz and 32 gigabit RAM. We use for UrbaWind 2.2 the version. So you can see that if you use a very small project with a radius about 100 meters with roughly 20 detached buildings, the the time of computation is 5 minutes. It's not very long. And if you increase the radius for a suburbs configuration, for example, with 200 meters, the time of computation is close to half an hour. It's not very long too. Usually we use it for a larger configuration for suburbs or downtown, and the time of computation can increase up to 3 hours or 20 hours. But it's not very long compared to other commercial CFD software, because UrbaWind is optimized for that. Thank you for your attention. If you have any question, do not hesitate to chat. I think we have time for that. So the chat, you can chat with only with me, or you can chat with all the attendees. Up to you. Okay. I'm waiting. Do not hesitate. It's open. The question is, are we able to get this webinar in video or the PPT, for example? Yes, we will send to you the PPT and but the video, I don't know if we share the video, but the PPT is okay. Yes. Don't be sure that your email is okay. But I think we send to the attendees today. Another attendee asked me, I had request a trial. Yes, you can connect. You can go on the website of Methodin and have a training version. The training version is not a full trial, but you can use it to discover the software. If you want to have a computation, full computation is not possible with UrbaWind, but ask us. We can have a Skype session to show you the advantages on your project of UrbaWind. Other question. You ever look at comfort? Yes, there was a question about we can assess the comfort close to Windows, open Windows. It's okay, we can do it. It's a question of mesh, but UrbaWind can do it. No, we have not UrbaWind in the cloud. We UrbaWind version are set up on computer or server, but there is no cloud computing version. Other question. I don't know. There is no Grasshopper plugin to access Win. No. But when we use CAD software, you export STL file in order to it's an input to UrbaWind. A question about safety. This is the same approach, because in UrbaWind you can change the coefficient alpha. Do you remember in the presentation? So if you want to assess the safety, you can change the coefficient. Other question. A question about how can you have an UrbaWind in ask to us? There is no problem. I think it's important to know and to keep in this information about how to contact us. So we have an email at the end of my presentation here, and you can ask everything on the info@methodin.com. Okay. Yes, we have educational license. Ask us. Next question, what kind of data do we get from computation? I told you before, you need the definition of the geometries and you need climatological data to assess the comfort. In UrbaWind, we use a turbulence model. This is a KL model, and we have a calibration of this model in order to reproduce the effect of turbulence on the flow separation. So there is some calibration to do that. We don't use K epsilon model because K epsilon model is very time consuming and not better than KL model. In humans, we have a presentation in building simulation in India. This is a conference, so we have a presentation about the performance of UrbaWind and the calibration of the model for urban wind. So there is lot of question. I suggest we give you all the information with the document. So you can ask your question directly on info@methodin.com, and you can continue this chat because I have lot of questions. So it's difficult for me to answer because now we are 50%. Okay. I think
thanks a lot for your presentation.
Thank you to all the attendees and keep in touch. Thank you a lot.
Thanks again.